Hey guys, so we are going to talk today about a derivative. And you can see here that we have a definition of a derivative. Don't let this freak you out, it's really not hard. But the derivatives themselves are a huge, huge part of calculus. So let me kind of explain how this works, and I'll put it in terms of something that you're more familiar with. So like, let's say I have an xy axis, right? And let's say I graph some line like this. Now, you would agree, I think, that this slope is positive, and it's also constant. So in other words, like if I was going up 2 over 3, up 2 over 3, up 2 over 3, I'm always going up 2 over 3 the whole time throughout the entirety of this curve. Okay, or this line, let's just say. So again, the slope here is a constant term. Okay, like I said, up 2 over 3. Now, what's going to end up happening now is we are going to be looking into, let me just draw you a picture. Let's take something easy. Let's pretend that hits at 0, 0. So if you look at this curve, it's a parabola, right? Now, the slope here is decreasing, and the slope here is increasing. So not consistent or constant like it was over here. The other thing is, look at the slope, let's say right around here. It's going up, right? But it's kind of shallow down here. But if you get up more toward here, do you see that the curve is a little steeper here? The same thing over here. On the left side, I'm a little shallow here, but as I work my way up the curve on the left side here, you can see that it's a lot steeper here. So the slope throughout this curve y equals x squared is constantly changing, all right, as opposed to this one where it's just always a constant. So because this slope is changing and it's not a constant, they've come up with something called a derivative. And really all derivative is slope. That's really all a derivative is. And if you look at this here, do you see that f of anything, that's a y value. And this is another y value. They're differentiating with the h here, just showing you that this is the function at some y value minus the function at another. Okay, or I should say at some x value. So this is really y2 minus y1. So let me write that for you. So this is really y2 minus y1. Now believe it or not, I know this h is here, and I'm just going to kind of go like this. It is correct, by the way. But then it would be over x2 minus x1. So again, I'm going to repeat again. So a derivative is just a way to find the slope of a function when the slope isn't a constant like this. Okay, I'm going to say that one more time, and if you want to write that down, write that down. The derivative is just a way to find slope of a function when the slope isn't constant. Okay, again, this is constant, this is not. Now, what's also going to happen is, as I said to you, the slope will be different at different points on the curve. So again, here, the function is a little steeper and negative, and here it's a little shallower, still negative. But over here, now it's positive, a little shallow, but up here, it's a little steeper. Okay, kind of think of like a ski slope. It's a lot steeper in these points up here as opposed to these points down here. That would be me. I'd be down on the little bunny hill. Okay, so when we find a derivative, basically we're going to find how steep the curve is at this point. Or we could find the derivative and find out how steep the curve is here at this point, and so on and so on. So we could have a derivative, but at certain points our slope is going to be different. Okay, so what we're going to start with is just finding a formula, and I'll explain it as we kind of get a little further into it. All right, so what I'd like you to do is look below this, and you will see that we have, well, you've got 8 examples there. I'm going to just take the first 2 first. Okay. So it says to find the derivative of the following functions. There's a formula. I just think it's a lot easier to go like this. So here we go. So you're going to write y prime. That's the symbol for derivative. Okay, there are other symbols, but for right now, y prime is it. So what you're going to do is you're going to take the exponent and you're going to bring it down in front here and multiply it by that 4. So you're going to take that 5 and multiply it by that 4. Okay, so that's going to give me 20. And then what you do is you're going to take this exponent and you're going to reduce it by 1. In other words, subtract 1. So that's going to be 20x to the 4th. You just took a derivative. Okay, now we're going to do that again. So I'm going to take this exponent 3, I'm going to drop it down in front and multiply it by what's in front. So that's going to make that minus 21x. And then remember, we just take the exponent and we reduce that by 1, which would make that to the 2nd power, right? So squared plus, and here we go again. Now, we technically have a 1 here. So 1 times 2 is 2, right? So that's going to be 2x. And because that power was a 1, if we reduce it, that's a 0. I'm going to talk about that in a minute. Okay. Now, this 5 at the end here there is no x value here. So let me talk about this right now. Isn't anything to the 0 power just 1? So if that's the case, this really right here is x to the 0. Okay, if we have to put it as some, including some variable, x, oh my gosh, sorry guys, that's 5x to the 0. So just bear with me a second. If I take this 0 and I multiply it by 5, don't I get 0? And then 0 times anything, even if I reduce this by 1 and make this x to the negative 1, it's 0. So let me just make a blanket statement. This originally was a 5. Any constant's derivative disappears. So this will just disappear. I'm not even bothering to write it. Okay? It'll make more sense as we go through this. All right, so now let's just kind of tidy this up a little bit. So I've got y prime equals 20 x to the 4th minus 21x squared. And then anything to the 0 power, remember, is 1. So that's really just 2 times 1, which is 2. And there's your derivative. Now, you may be asking, wait, that's not a slope. You're right, it isn't. I mean, it is, but it isn't. This is an expression for the slope. And then remember how I told you the slope's going to be different at different points on the graph? What you'll do is they'll give you like an x value and you'll plug it in here, and you'll get a numerical value for it. We're just not there yet. We're just figuring out the basic derivative expression, so to speak. This is an expression. And then we'll figure out the numerical value in a couple of days, okay? All right. So I just want to kind of go back. So any constant, its derivative disappears. And any variable that just, excuse me, any number that just has an x, look at what happens to it. 2x just becomes a 2. Okay, so if this was a 5x, that would be a 5. If that was a negative 7x, that would be a negative 7. All right? Okay, why don't we try number 2? So we're going to do the same thing. So we're going to write y, oops, maybe I should get my pen moving here, right? Okay, make sure you're taking notes. Put this in your packet. Y prime equals. All right, so we're going to take that first term, that t squared. We're going to bring that 2 down in front because it's getting multiplied by 1, which is really just 2. T, and then reduce the power by 1. Well, since this is a 2, I'm going to reduce that by 1. So that's technically a 1 here. I'm not going to write it. You don't have to. Okay, plus. Now here we go. These are the couple of tricks that I was mentioning on this one. See this one over here? Its derivative was just the number in front. So here, the derivative is just the number in front. okay? So that's just going to be plus 2. And remember, the derivative of any constant disappears, so we don't even have to write it. So this is your answer. Okay, and again, it's just an expression for slope. Once we start plugging in numbers, we'll get a numerical value. All right, let's go to number 3. So we have y prime equals, well, this is an easy one, isn't it? 2. Okay, because anything with the variable x, just a plain x to the first power, just whatever number's in front, that's your derivative. Constants cancel out. All right, you didn't think it was going to be that easy, did you? But now look at number 4. Okay, so y prime equals, now remember, this 1/3 is getting multiplied by 3. Well, 1/3 times 3, isn't that just 1? X. Okay, now, you have a 1/3 power right now, and you need to subtract 1 from it. The way I like to do it, and I kind of can't fit it because it's written so small, so I'm just going to put it right here. 1/3 is your power, and you're subtracting 1 from it, which is really like subtracting 3/3, right? And then that way I have a common denominator. So when I do that, I'm going to get negative 2/3 as a power. Okay, let's go to the next one. I'm going to be doing 3 halves times that 6. Okay, so you're going to multiply those, and you're going to get 9x. And then I'm going to write this over here just so you can see it. I'm taking 3 halves, and I'm subtracting 1 from it. I'm going to keep it 2/2 so that I have the common denominators. Okay, so when I subtract that, I'm going to end up with 1/2. And then 8's derivative cancels out. Okay, so there's your answer for 3. And as ugly as that is, there's your answer for 4. Now, we are going to eventually simplify these a little bit more. In other words, I know an exponent that's negative means it's in the denominator. And if you remember from Algebra 2, this is the power and this is the root. So it's really the cube root of x squared. Okay. Likewise over here from Algebra 2, you should remember that anything to the 1/2 power is the same thing as radical x. So this is the same value. And I want you to know that because you're going to get some multiple choice questions. And I'm telling you, you'll never see this. You will always see that. Okay? All right, so let's look at the rest on this page. Now, if you think you got the hang of this, pause me. And how about let's do that. Pause me now, do 5, 6, 7, 8, and then unpause, and I will, then you can check all your answers, okay? Okay, there's your answers for 5 and 6. I think those are pretty straightforward. Now, with number 7, if I were you, before you take the derivative, I would bring that, fractions are icky. So if you can, remember what I did on the last one. If you have a negative exponent, you can bring it down to the denominator to make it positive. Well, why not bring it up to the numerator so I can figure out how to take the derivative of this thing? So now all I'm going to do is I'm going to, and again, just remember, I just took this and brought it up so that I have it as an exponent and no fraction. Now we take this exponent, multiply it by that number in front, and I'm going to get negative 8x. Now here's the part you have to be a little bit careful of. We have to subtract 1 from this. So I'm already at negative 8. If I subtract 1, then that's going to be negative 9. Okay, now that's an acceptable answer. But again, I'm going to encourage you to make sure that you understand that that's really x to the 9th in the denominator. Now the negative 8 isn't part of the x to the negative 9th part, so we leave that here. So these are both the correct answer, but again, I really encourage you to make sure that you understand how to do the second one right here, okay? All right, so let's look at number 8. So I've got f prime of x, that should be 50 x to the 9th plus 7 x to the 8th minus 40 x to the 7th. And I'm not going to be able to fit this, so I'm going to have to stick this down here. Now, do not get swayed by this pi. That's like it's 3.14, but that's like a number. So what you're doing is you're taking this 5 and you're multiplying it by pi. Okay? And you don't need a calculator, just write it as 5 pi. So that's going to be 5 pi x to the 4th. Okay? And like I said, this really should be up here. I just can't fit it. Ooh, and that's a positive, right? So I should put that in there. Okay, so positive right there. So here's your answer for that one. And there's 5 and 6. Okie doke, I would like you to turn 2 pages and let's go to number 17. Okay, so why don't you try 17 on your own and then unpause the video and check your answer. So to find f prime in simplified form, then just remember again, x to the negative 1/3 is x to the positive 1/3 in the denominator. Okay, so this is going to go down to the denominator. Remember, it's power over root. So it's going to be the 3rd root, and technically of x to the 1st power. You don't have to write that one, but and there's the equivalent form. All right, now let's look at 18. All right, 18 is going to be a little ugly, so I am just going to rewrite it without taking the derivative yet. So that's going to be 7, and I want to get it out of radical form. Whenever you have a radical, get it into exponential form, and what I mean by that is like what you see here, because it's easier to take the derivative. Okay, so if I do power over root there, that's going to give me x to the power over root plus, and be careful with this one. I can write this, and it'll be easier if you write it as 2/3 and then the x to the 4th next to it. You'll see why in a minute. And then minus 6x. All right, let me just get this. So I am going to take the derivative. We're going to take this 2/3 and we're going to multiply it by 7. So that's going to be 14/3. Doesn't matter if it's ugly, that's what it is. So we've got 14/3 x. And then remember, really what we're doing is we're subtracting 1 from that 2/3. So in other words, I'm going to subtract 1 in the form of minus 3/3 because I wanted to have the same denominator. It's just easier for subtracting purposes. So that's going to end up giving me negative 1/3. Okay, and then this is why I brought the 2/3 in front, because I'm going to do 4 times 2/3, and that will be 8/3. So that's going to be plus 8/3 x to the 3rd, and then minus 6x. Remember, whenever we just have an x, our derivative will just be minus 6. Okay, and there's your derivative. Now if you want to write that as a fraction, the 14 is going to stay in the numerator, the 3 goes in the denominator, and that x to the negative 1/3, remember that comes down to the bottom, and it's power over root. So that's really the cube root of x, technically to the 1st power, but I'm not going to write that. And everything else you can pretty much leave as is. So 8/3 x cubed minus 6. Okay, so both of these answers are acceptable, but you're really going to need to know how to do that bottom form. Okay, so you may want to take a couple of minutes, pause me, do 19 and 20, get everything out of fraction form if you can, like on 19. And with 20, do your power over root, get rid of all those radicals, as well as in 19 as well. Okay, pause me, work that out, and then come back on and check your answers. Okay, so this is the way I would rewrite your f of x before you even start taking the derivative. Okay, so if you're checking that, check it, fix anything you need to fix, and if you need to, redo your derivative and pause me. Okay, there's the next step at number 19. You just take the derivative, reduce your exponents by 1. Be careful when you're reducing negative 3 by 1, it actually becomes negative 4. And here, I'm reducing by 1, which is negative 4/3. Now, that's an acceptable answer. I'm going to rewrite that, or I would suggest that you know how to rewrite that as a fraction. And there's your answer in fraction form. All right, a couple little tricky parts right here. Just make sure when you're multiplying this 2/5 times 10, that's 20 over 5, and 20 over 5 is 4. That's where that came from. And then when I am subtracting 1, just remember, this is going to look ugly, but I am subtracting 5/5, and that's where I got the negative 3/5 from. And then here, same thing, 5 times 4/5 is 4, and that part's pretty easy, okay? And then I would just also make sure that you understand how to turn that into a fraction. So we've got 4 over, what do we got? Power over root, right? So that's going to be the 5th root of x cubed. And this will probably make more sense to you why I'm doing all of this stuff when we get to, I think it's unit 11 or 12. Then we use it a lot, okay? All right, so go ahead and do 21 and 22. Now 22, if I were you, before you start that one, I would probably double distribute and then take the derivative. It'll be pretty easy once you double distribute that first. So go ahead and do that, pause the video, work them out, and then unpause and see what you got. There's your answer to 21. So I made this x to the negative first. Now be careful here, this is so much easier. Please try to get in the habit of, if it's just, well, anything really, this is just an x. This is really 1/2 x. The reason why I do that is it makes it so much easier than to take the derivative, because remember, anything with just an x next to it, its derivative is just whatever that constant is in front of it. So I find that to be a lot easier if you set your original function up like that. Okay, and let's just go that one extra step. This is going to be negative 2 over x squared, and we can leave this as plus 1/2. Okay. All right, go ahead, work on 22 if you did not finish that one. Double distribute first before you take the derivative. This is what you should get once you've double distributed. We can just go ahead and take the derivative. All right, so that's going to be 14x to the 6th minus 20x cubed plus 48 x to the 5th and minus 60 x squared. And that's a nice easy one. We don't have to make a fraction or anything. Okay, last two, 23, 24. I think you got these on your own. So go ahead and work on them and press pause and then unpause when you're done to check. There's number 23. And there's number 24. All right, so at this point, once you've checked everything and you feel good with it, just check Google Classroom and you're going to do the homework that is assigned on Google Classroom.